All right, so welcome back, and thank you for joining me once again. You should have just finished the random class video, and now, as promised, we'll be talking about file input and output in Java. So, Java allows you to create and read files using a few Java objects, which we'll be introduced to in this video. So, remember Java objects are friends like string, scanner, random, math, and now we'll be introduced, excuse me, to a few file-based objects that we'll be working with to handle files. So these objects include PrintWriter, FileWriter, file, and actually scanner is used to read files. Tonight and in these videos, we'll primarily be focused just on PrintWriter and FileWriter. So these objects must be imported similarly to scanner, except while scanner is in java.util and also random is in java.util, the file type objects are in a different location called java.io. So when you need these IO, which means input output, like writing to files or reading from files, when you need objects like this, they're in this class, these classes that come with Java that are under IO, like this. So this is how you'll just do an import statement at the top of your files that use PrintWriter and FileWriter and file. I would show you the OpenJDK source code, but I don't actually have internet right now. Crazy. All right. So the first object, should I say, is a new object for us, and it's called PrintWriter. And this object, aka class, allows you to write data to a file. So I believe that it's called PrintWriter because it supports the print and print line methods, just like we use with system.output. The way you write text to a file using the PrintWriter object is you simply say print line. So I don't want to skip too far ahead, but you can see here, print line. To open a file for text output, you create an instance or you instantiate an object of the PrintWriter class. So the basic instantiation line is like this. PrintWriter, and then you give it you make a local copy, and you just give it any name you want, and then equals new PrintWriter, and PrintWriter takes as an argument the file name that you want to access. Okay, so in this instance, we're saying we want access to a new file, or we want to do something with a new file, and in this case, it's called student data. So a quick warning, a very important warning, if this file already exists, it will be erased and replaced with the new file every time you run the program. So you don't want to overwrite your diary entry or something. You do have to be careful with that because it will just overwrite whatever's in there. So it has a lot of power. Unless you specify a directory, which you can do and we'll talk about in a later video, the file is written in the location where the Java class is run from. So we'll see that in IntelliJ in just a moment. As I mentioned above, the PrintWriter class allows you to write data to a file using print and printline and even printf methods, as you have been doing to display formatted data on the screen. Yeah, just as with system.out. And very similar to system.out.println, when you call println on a PrintWriter instance variable, the PrintWriter class will print a new line character after the data is written. So we'll see some demos of that. And just like you would expect, the print method just like with scanner, system.out, print method does not insert a new line character. So we'll see some demos of that. So yeah, basically we're going to use this information as our starting point, something like this. So let's head over to IntelliJ. All right. Whoops. Zoom in. Okay. So I just wrote this class. It uses the import statement and it throws a file not found exception. So this is something new, and we're going to talk about exceptions in the next video. But don't need to worry too much about it at this point. Anyway, so since we have imported the IO classes to our working file, all we need to do is instantiate a new PrintWriter object. And actually, I guess really quickly before we do that, let me just show you what that would look like if you, for example, forgot to import it. So if I said PrintWriter output equals new PrintWriter, my file.text. Well, it was already imported, I guess. So if it was not, if I forgot to do that, the import, it would be red, and then I would have to import the class. And this exception is also part of the java.io library of classes. So if we just instead put an asterisk, we say, let's make all the classes in java.io available to us. That's how this will work. Okay. So the first line here, we make an instance of PrintWriter. We just call it output file, and we'll just say we want it to have the name printstudentdata.txt, and then we run a print line statement, and we'll say enter the name Mike, next line Donnie, say Mary, okay, and then close. So very straightforward. Before we run it, this file, I just happened to call it PrintWriter demo pass up line. That just has to do with exceptions. But look here, take a look there when we run this, because we're going to run this code and nothing's going to print to the console, but we're going to get a new file called printstudentdata.txt. And so this file was created in the directory where this program was run. Okay, and then as mentioned before in the lecture part, anytime you rerun this code, this file gets totally rewritten. So if we change it to, Barry, Donnie, and Mary, and we run the code again, this totally separate file is changed every single time you run it. So you can never append anything. I also wanted to, show another quick demo. So let's say we run this and we get the three names, Barry, Donnie, Mary, sure. Now, if instead of print line, I say print, we get them written on one line here. But if we add back in the print line command and we run it, it goes back and inserts a new line after each statement. And then I mentioned that printf is also supported. So imagine that you change this to these statements to printf, and then you said percentage, let's say 20s, comma, Barry, comma, Donnie, comma Mary, and run it. Okay, well, see, remember that printf does not add in the new line character, just like print. So let's add that in as well. And we'll run this. Okay, look, and then so our file is written with 20 width of a string on each line. So that's kind of what I would consider a first level usage of it. I would say a second level usage of it, of this class, of the PrintWriter, would be something like this. Okay, so I've inserted the code from the notes into here, and of course I had not yet imported my scanner, so it just prompted me to do that. I have my java.io classes imported, and so what this is doing, it's not really adding anything new, but it's simply combining two objects. So we have our scanner object, our keyboard, and then we have our output file, and then we have a for loop here, and it says as long as I is less than 4, let's ask the user to enter a student's name, and then after the user enters a student's name, we'll write that name to the file. And then after all the names have been added, we just print out a little count, and it's I minus 1, because remember, if we're incrementing with a for loop, it increments past this condition. So I becomes 4 eventually, and is 4 less than 4? That's where we say no, that's false, and then we break out of the for loop. So at that point, I is 4. So we would say we wrote I less than 1 student names to the file. You might also notice, talking about initializing variables being self-contained within a for loop, which is not something I'm doing here. I'm choosing to initialize the variable outside of the for loop so that it has scope, so that I can reference it later outside of the for loop, because I want to kind of know at the end of it how many names I wrote. In fact, I guess I could use an accumulator variable here. Int total equals 0, and then keep my scope of I within the loop. Whoops. That would probably be better, right? That's better Java. So we'll say total equals I. Yeah, this will be nice. That should be 3. Okay, cool. So yeah, accumulator variables, this file really has it all. Okay, so student 1's name, let's just go with Sarah. Why not? Student 2's name, Judith, and student 3, let's go with Peter. All right, so we wrote 3 student names to file. So we wrote that inside of the same directory, and so you see we've got our 3 students here. However, of course, if we run it again and we use different names, Mike, Jamie, Pat, it wrote 3 names to the file, but we look at the file and the names are different. So this is PrintWriter. This is the PrintWriter object. It does those things. It does more things than that. It can do more things than that with the methods it has available to us. But for our purposes, these are primarily what we'll be using it for, to write data to the file. The only downside, or potential downside, is that it always overwrites the file. So you have to be very careful. It's destructive of existing data. And we'll learn ways to avoid that next. Okay, so this video is about exceptions in Java. When something unexpected happens in a Java program, an exception is thrown. Some Java classes require you to throw an exception. This is the Java object's way of forcing you to tell the user why the program didn't work or why the instance of the class didn't work. So let's dig into this. So you may have noticed when using PrintWriter that the main method has these additional words. It doesn't just say public static void main string args. It has main string args throws file not found exception. And we even saw that if we don't import all the classes from java.io, Java doesn't know what this exception means. So it's part of the java.io library. The new words in the main method signature, throws, file not found exception, indicate that a user could run into the problem of not being able to create a file or that the file doesn't exist in the specified location. If you hover over PrintWriter in IntelliJ, you'll see that PrintWriter takes one parameter, a string, which should be the file name or is the file name, and it throws one exception, the file not found exception, which is thrown under these conditions. If the given string does not denote an existing writable regular file and a new regular file of that name cannot be created, or if some other error occurs while opening or creating the file. So let's just see what that looks like in IntelliJ. Hover this and it says it throws this file not found exception. It also throws another exception, but that has to do with security. So that's okay. So one of the ways that this error can be encountered is if you enter an invalid file name. So if I want to make a PrintWriter and it has no file name, it should throw an exception. And the exception gives me this message, no such file or directory. So that's what is meant by throws file not found exception. However, the method that is executing when the exception is thrown, which in our case is the main method, it must either handle the exception or pass it up the line. When an exception, which is an error or an unexpected event, occurs in a method, the method has two choices. It can handle the exception, which means that the method can have a try-catch block. It can catch and manage the exception using a try-catch block, which means that the method takes responsibility for dealing with the error. We'll see an example of this. Or it can pass it up the line to the method signature using the throws call. This means that the responsibility for handling the exception is passed to the method that called it. Okay, here's an example of handling an exception using a try-catch block. And we're going to cover this in a later lesson, but this is just to inform you, is that you see this method right here also uses PrintWriter, but it doesn't have the word throws file not found exception. Instead, what it has is a try, the word try, and then code within the block, which is to say we're going to try to do this stuff. And usually, of course, you want to have a file specified. But if you don't, like in this case, you're going to get an exception. So what we did in this file is we caught the exception using a catch block. And what happens when we run into an exception? when we define it using try catch is we can tell the user what went wrong, and we can handle it ourselves. And what happens is you get a message that says can't write to this location, and we'll take a look at that. But right now what we're focused on is passing the exception up the line. To do this, the method uses a throws clause in the method header. To insert a throws clause in the method header, simply add the word throws and the name of the expected exception. Since PrintWriter throws file not found exception, we write the throw clause like so. File not found exception. There are many different types of exceptions used by Java objects. FileWriter, another type of object, uses files, throws a different exception. It throws an IO exception. So we write the throws clause like this. So we're making a FileWriter object, and we have to throw an IO exception. It's a different kind of an exception. There is a list of common Java errors and exception types, which you'll have a link to in the notes. Now, you might be thinking, what if I use two objects that each throw different exceptions? In some cases, you must declare each exception after the throws keyword in the method signature. So public static void main string args throws file not found exception, comma, IO exception, and then you could use both PrintWriter and FileWriter. However, in this particular case, however, there is a hierarchy of exceptions, and in this particular case, the file not found exception is a specific exception within IO exception. So if you hover the file not found exception in IntelliJ, you see the message, there's a more general exception, java.io.io exception in the throws list already. So you can safely remove the file not found exception and only keep the IO exception. So let's just take a quick look at that. So in this example, we've already seen you run it and we get this exception. File not found, no such file or directory, because it has a name that Java can't understand because there's nothing in it. All right. Now, we could alternatively write it as a try catch block. So in this case, there's no throws here. And this, let's say this is a bad file name, so it's not going to run. But when we run it this time, we handle the exception ourselves. We tell the user we can't write to this location, and we throw the exception. But the program doesn't crash, it just exits gracefully. So those are the two ways to handle an exception. It's either required explicitly in the method header, or you handle it yourself and you just you can use it to write any kind of custom error message. Finally, when you're working with two objects that each throw their own exception, like FileWriter, which if you hover over it in IntelliJ, tells you what's the parameters it takes, and it tells you what exceptions it throws, and since it throws IO exception, which is different than file not found, we need to throw the IO exception. But then when we do that, since we already have been working with PrintWriter, we see that it is listed in dark gray, and we hover over it in IntelliJ, and IntelliJ tells us there is a more general exception, the IO exception, in the throws list already. So it recommends us to just remove this because it's covered by the IO exception. So because there's kind of a hierarchy of exceptions, it's all set. So in a nutshell, so briefly, this is how exceptions work in Java. All right, the next topic is the object called FileWriter, and this is about appending data to a file. So we've just taken a look at it with regards to exceptions because the error message must change when we start using FileWriter. But what does FileWriter actually do, and what does it actually give us? Well, FileWriter is a way to avoid erasing a file that already exists. Because with it, you can append data to the end of the file, not just write it from the beginning of the file. For our purposes, we're generally going to be combining it with the PrintWriter object. So what that means is essentially we instantiate a FileWriter object that we call FW because this object is better at writing data to files because it allows us to append data at the end, and we'll see what that how that's achieved. Because remember, PrintWriter, which we're familiar with on the next line here, it only accepts one parameter, which is a file name or a location. And FileWriter is both a location and a command that allows you to write data at the end of a file if this is true. The two statements can be combined into a single statement, so that is supported. But you don't have to do it like that. The reason to use these two objects instead of just one together is because of the FileWriter construction, which has a file and a Boolean as to whether to append data to the end of the file. Calling FileWriter with these two arguments creates a FileWriter object using a named file object, whether it exists or it doesn't exist, as long as the location is accessible. But if the second argument is true, the bytes will be written to the end of the file rather than the beginning, letting us append data rather than overwrite it. FileWriter throws an I/O exception under the following conditions. If the named file exists, but it is a directory rather than a regular file, if it does not exist but cannot be created, or it cannot be opened for any other reason. After you instantiate the FileWriter object, write to it as you would with the PrintWriter methods, print, printline, or printf. So essentially, we treat it the exact same way, except we create the file using FileWriter rather than PrintWriter, which supports file creation but doesn't give you the flexibility to append data to the file. But after we do that, we just work as we did before normally. So using the print statements to this PrintWriter object. So we'll just have a quick look at that. So we'll just take a quick look at that. First, well, you know what? Let's just copy this data. I'll import the FileWriter class. But then when I do that, it doesn't understand what is PrintWriter. And remember, I told you guys that they're in the same class. So we just say, give me all of the java.io classes. Now, we still have the issue, which we hover over with FileWriter, and it says unhandled exception because FileWriter requires you to throw or handle the IO exception. So we'll just throw it up to the method signature like that. So what we're going to be doing is, let's see, remember our print student data text file? So print student data.text. So in this case, we'll be adding data to this file. Right now it looks like this, Mike, Jamie, Pat. And we'll be adding some more data to it. So if we run this file, we don't have any errors down here. We look at the file and we get the names at the end. So this is how you append data. you can also create files with this. So let's say I had print student data 2. So if we look in our file explorer over here, we don't have a file called as that. So we run this and we get a file called like as that. And then we go ahead and run it again. And we have our ever-growing list. So this is the way to append data to a file using FileWriter, because it has this parameter here, which PrintWriter does not. So it's relatively straightforward once you are familiar, after you're familiar with PrintWriter. So we'll see you in the next video. All right, so the last piece of content for tonight is specifying a location for your file. Now, I may have to return to this on Tuesday night after I get back to my Windows computer and find some more information for you guys, because right now I'm on a Mac. But anyway, it works on both systems. So using PrintWriter or FileWriter, you're not limited to running the file and saving it or reading from it just in the directory where you run it from. Like we saw in IntelliJ that we were writing files and we were writing them right in the same directory. So on my computer, these would be right in chapter 4, just like all the source code files, because we ran it from here. But we're not limited to that with either PrintWriter or FileWriter. And the way we do that is we specify the file path in the file name parameter. However, I should say, or I must say, that on Windows, the paths are written differently than on Mac, and it's kind of a headache a little bit, because the / character in Java is used to indicate an escape, and it's an escape character. So if I may just show this, remember in Java, if we type something like \n or \t, system.output.print, and I say \n, that's going to print a new line character. Or if I say \t, that's going to print a tab. So it's a problem in Java when I want to write out a Windows file path, because I'm sure you're familiar that with Windows, on the C drive, it starts as C:\\, it might be users, and then this would be your username. So whatever your username is that's like unique to you, and then you might have a desktop folder, for example. So this is a path. This is a location on your Windows computer. Well, the problem is in Java tries to interpret this \u as some type of an escape character. So if your name was Nick, it would see this \n, and it would not write \Nick, it would put a new line in there. So it's a problem. It's a problem. But the way you avoid that problem is you double / every time you need a \. So it looks a little funny, looks a little weird, and it's kind of hard to get used to, but that's the way it is on Windows. So you must tell the compiler not to by typing 2 of them in a row. For example, a location you might want to use is your OneDrive account. So you would specify it as something like this. If it's on your C drive, there's usually a folder called users, and then you have a username, which would be your name or something like that. And then maybe it would say OneDrive Bentley University, and then within there you have a CS180 folder. and then finally the name of the file that you want to write. And if this is in your Java code, it will write to that location if it exists. But typing all this out can be cumbersome. So there is a way that you can have a bit of a shortcut for this. So remember, or we all know system.out and system.in. The system object has many methods and properties that you can access, and one of them is called get property, and within there's something called user.home. And so that's your home directory regardless of whether you're on a Mac or Windows. And you could make use of this information to make your program more portable. So for example, if you had a FileWriter object, you would say new FileWriter system.getProperty user.home plus and then in a string, wherever your OneDrive is, and then the file name, and then append. So if I shared this program with you, FileWriter wouldn't look in my home directory /users/Pete, but whatever your home directory is, regardless of whether you're on a Mac or Windows. So let's take a look at this. Okay, so really quickly, it can be a little tricky. So just very quickly, it can be a little tricky to get the full path for your OneDrive folder, for example. But mine is right here. And if you're using Windows, you can find it in the Window File Explorer by clicking in the box with the path and copying it. You can do it in Mac too, but I'll get that information for you by Tuesday. So anyway, this is a path on my computer, and what's in it are just some information that I have for our class. But you don't see any text files or anything like that in there. Right, there's no text files in here. So if we go to IntelliJ, let's say we have our FileWriter, and I will say that I want to write to this path. You see, I want to create a file in /users/p/documents/OneDrive Bentley University /CS180, and then just for readability's sake, I want to say that I just added a plus sign here, and then I want to say print student data 2.txt, and I'll get rid of the File Explorer. Okay, so we run this file, no errors. So we go to our Finder, and now we see print student data 2.txt. Okay, so that's how you specify a path. And we also can say system.getProperty user.home. Get rid of this because that's my home directory, and then just run it like this. And let's add a couple new names. Run the program. It exited without any errors. Go back to my Finder, open this, and see this program has written the data to a file somewhere else on my computer. So I hope this gives you a sense of using FileWriter or PrintWriter. You could specify it the same way with PrintWriter, but you can specify more than just running it in the directory where you're in. Now, the last thing I just want to quickly mention that there's some more information I need to get for you all by Tuesday, which I intend to do. For example, testing on a string literal versus string object for Windows style file paths. Figure out if Unix style file names work on Windows. I'm not on Windows right now, so I can't test it. And then accessing system variables, and there might be a system variable on Windows that directly takes you to OneDrive. So if I can find that for you guys, that would be very cool, because then we might just be able to say something like get property OneDrive, and then you could simply avoid all of that, and it would go right to the OneDrive, and then you could just specify it from within OneDrive. So I want to make sure that if that exists. All right, so that's the content for tonight, and please email me if you have any questions, and I'll set up extra office hours, and I just really appreciate your understanding and cooperation, and please, I'm always here to help. So anything you need, just please email me, and I will see you in class on Tuesday. All right, have a great weekend, and be well, everybody. I'll see you soon. Thanks for tuning in. Thank you for watching.